Okay, so number 16 is an interesting problem. So all of the rectangles in this given figure are similar, which drawn to scale, which usually they say not drawn to scale, but in this case they say it is. Similar to the enclosing rectangle, the larger one. Each number represents the area of each rectangle, and then what is the distance between A and B. Okay, so what we are gonna do, like we have a lot of information. Normally, like when you have less information, you kind of don't know what to do. But in this problem, we have too many information, and then you don't really kind of don't know what to do, how to start even with these numbers. So what I'm gonna say, we are told they are similar figures. So which is the only kind of important, I would say, important information we can start with, because if you have two figures are similar, then their areas actually is square of their like the scale. Okay, so in this case, we are given the areas, right? So maybe I can just use that to square root of the areas to write the side length for each rectangle to see if that's going to help us somehow. So if you take the square root of this 36, that's going to be 6. I want to say this is 6x, and then this side will be 6y. So just imagine this, the shorter leg will be multiple of x, and the longer leg will be multiple of y. So, and this is 4, so the shorter will be 4 times that, so which is 4x, and then there will be 4y. So like we can say this is 6y, this is 4y, so you can immediately say this is 2y, which makes sense because if you take the square root of this, you get 2, so that's the longer leg. So that means this side should be 2x. Basically, we can say this is going to be 2x as well because this was 4. But at the same time, this is the longer leg. Maybe I should take the square root of 2, which is root 2. So the longer one will be in terms of y. So that means this is going to be y root 2. And then this is going to be x root 2. But right here, we have something already. So this y root 2 is the same as 2x because this plus this is equal to 4x. So if you multiply both sides by root 2, so you get root 2 times x is equal to y. So I'm going to use this soon. So as soon as we have this, we can kind of, this is promising because we already got something, right? So if I take the square root of 8, and then I'm trying to write each sides in terms of x and y, so we can actually get something. So that will be 2 root 2. The longer leg y in terms of y, so that will be 2 root 2x. And then this is going to be 3 root 2y. And then this is going to be 3 root 2x. And then that will be 7. 7y is the longer one. And then this is 7x. This is 5x. And then this is going to be 4 root 2y because that's the longer one. Okay, so now at the same time, okay, so if I want to make this equal to this, I hope like I probably like I wish I would get something else other than this one. But if I make this equal to this, that should probably give us y equals x root 2 as well. So which doesn't really make anything new. So we just want to get something else. So but we kind of use some of these numbers, but we never use all together, right? So we just have a bunch of areas. If you add 32, 25 for all these areas, you end up getting 200, which is actually nice because we can write the area in terms of the side length, so we can get x or y from there. So this segment is 12x plus 4 root 2 y. And then the other segment is 7y plus 3 root 2x. So what we are going to do, we are going to multiply, but before we do, let's use this guy. So the y equals x times root 2. If I replace x root 2 right here, so root 2 will make 2. That will be 2 times 4 is 8. That will be 8x plus 12 is going to be 20x. And then this is going to be 7 root 2 plus this will be 10 root 2 x. So 200 times 10, 200, cancel 200. So you get x squared times root 2 equals 1. And then x squared is equal to 1 over root 2 or root 2 over 2. Okay, so it's getting something. So what we want is this segment, which is equal to this one, so that was equal to 20x. So we just need to get AB, which is 20x. X is not known. We know the x squared. So if I take the square root of this, so square root of 2 is going to be fourth root of 2 over square root of this will be square root of 2. But there is no choice like that, but this is kind of close. So we kind of need to get rid of this root 2. We may make this root 2 as 2 squares in square root, and then make that square root like fourth root. So what I'm trying to say, we can write that square root of 2 as this one, because that's going to be equal to just square root of 2. But now we have this guy in the denominator, so I just want to multiply this by fourth root of like 4, fourth root of 4 as well, so we can cancel that. So this is fourth root, this is fourth root, so this 4 times 4 is 16. That's why I multiply by this, so I can get nicer in the denominator. So that should be just fourth root of 16, which is going to be 2. So the numerator is 20 times fourth root of 2 times 4 is 8. So 20 and 2 will cancel. So you get 10 times fourth root of 8. So that was choice D. But this is actually one of the interesting problem on this test that I really like doing it. So this was number 16.